Hey guys, thanks for joining us. Dean's here with me, and we did not coordinate our shirt colors, by the way. It's a total accident. What I'd like to do is start with our remote speakers first, because it's always hard to make sure they get involved early and often. Dan Hayes and I have known each other for decades, although I think we had forgotten we knew each other. I think he started, when I first met Dan, he was probably a senior telecom analyst or something. Now he's, of course, a principal and a partner of PwC. And he's worked with virtually all of the largest 10 telecom service providers in the world, including NTT, of course, which is at least the second largest, and some people would argue maybe even the largest telecom in the world. So I'll start off with Dan and Hiroyuki getting your opinions on the status of 5G rollouts in Japan and then globally. And Dan, why don't you start?
Sure, thanks, Gary. And so sad that I can't be there with you in Hawaii. It's certainly got to be a lot warmer than it is here in Washington, D.C. today. But look, 5G has really gotten off to a good start, but not a great start. And I think it's fair to say that we're still in the early days when it comes to 5G, right? What we're really seeing is 5G as enhanced mobile broadband, right? Starting to get some faster speeds in some locations, continuing to roll out coverage in much of the world, including the US and Japan, right? We're not quite there yet, but we really haven't gotten to the true utility of 5G. We haven't gotten to some of the use cases that have been imagined, the network slicing, the ultra-fast consistent speeds, and some of the new uses for connectivity, such as mixed reality. We're just not there quite yet. Now, we've made some great progress, but I think at the same time, that we still are waiting for some of the standalone 5G networks to deliver on some of the promise of 5G. So, I sort of put us, to use the shared American-Japanese baseball analogy, I'd probably put us in about the third inning when it comes to 5G.
Hiroyuki, where are we? Third inning, or not so far along, or are we further along?
Okay. Very nice to meet you, everyone. And I'm Hiroyuki Oto. As Gary said, I have been working for NTT Docomo, a Japanese mobile phone company, for about 30 years. Currently, I'm the general manager of Core Network Development Department at Docomo, and I'm responsible for the development of 5G core network and its entire operating system also. Thank you very much for letting me participate in this panel today. Actually, I wanted to participate in Hawaii, but I'm sorry that I'm joining from very cold Japan today. And I'd like to enjoy a beautiful discussion with you today. And first of all, I would like to explain the current status of 5G in Japan.
So, Dean, I know you've got thoughts about 5G. So
I do have a few thoughts. I'm not going to make a sporting analogy, and especially not given what's been going on with English cricket in Australia. So I'm going to park the sports versions. But my view is that 5G, and I'm not going to win any friends with saying this, is just another G. It's not as special as people make out. It's not going to be ubiquitous. But most importantly, and Daniel already touched on this, it comes in phases. And to be honest, what we've had in most of the world with 5G so far is 4G++ in certain locations. And really all the cool things that people talk about with 5G, whether it's millisecond latency or network slicing or features for particular industries, they come in phases 2 and 3 and 4 of 5G. You can look up the official standards, release 16, 17, 18, and we're nowhere near that yet. And worse, it's going to be very patchy when it does get here. So the coolest bits of 5G probably won't work indoors in most places, for example, unless you have a dedicated indoor system. And I think that we have to be realistic. It's IoT and virtual reality, and frankly, anyone talks about virtual reality or autonomous vehicles and 5G, ignore them, because they are likely to be using other technologies or not connected. I think it's important to understand what 5G can do and what it can't, and I think we're still exploring that now. Fixed wireless access, actually, is perhaps one of the unspoken heroes here.
So Hiroyuki, two of the advantages of 5G you always hear about are the improved speed, sort of 10 times more than 4G. And we also hear about latency performance being probably another 10 times better than 4G. But we also hear about things like virtualization and network slicing. How important is network slicing in the virtualization of the 5G core network?
Okay. Can you hear me? Okay.
Yes.
And in my opinion, before the introduction of 5G, there were very high expectations around the world. However, the expected image is the final performance spec of 5G, and it is not something that can be used anywhere from the beginning of 5G service. But it will be realized by the gradual development of the technology, as you said. This has been the case of the past generation, and it has evolved in cycles of about 10 years. Each generation, like 3G and 4G, has eventually achieved a performance that far exceeds the original goal. And in terms of standardization, specification for 5G were finalized in release 15, as you know, and followed by release 16. Release 16 includes many improvements of functions. And further development is being discussed in subsequent releases. In addition to the development of standardization in 3GPP, we believe that the development of new technologies such as VR and AI will cooperate to create services for enterprises and consumers that take advantage of high speed, low latency, and high reliability feature of 5G. That's my opinion.
So Dan, why do we care about network slicing or virtual private networks if we care?
Yeah, well, I agree a lot with what Dean said in that I think that these things are means to an end, right? Virtualization is a mechanism to enable networks to be built quicker and potentially more cheaply. Although it's yet to really be proven out in most ways. I think that slicing is a way to provide more consistency of network performance for services. But again, at scale, are arguably not really proven out, although you could argue that, fiber optic networks and such have been doing this for decades. I think that what we really are looking at with 5G is to get improved performance and improved responsiveness to enable applications and services, right? That's what, as users, we all actually see and care about. I think what we aren't going to see with 5G is it's not going to solve many of the woes of mobile networks that have existed since the start of time when it comes to mobility. It doesn't solve gaps in coverage. It doesn't solve the economics of covering, rural areas with wireless signals. It doesn't change the laws of physics when it comes to the transmission of signals. And in fact, given that 5G now has extended the use of spectrum up into the millimeter wave space and into, the upper reaches of the sub-6 gigahertz band, as Dean said, it is likely that we'll see even more disparate experiences on 5G than we will in the past. I think, that has been proven already. And, all the advances in antenna technology will get us to a certain level, but they won't get us all the way to, the ubiquitous mobile experience that many seem to think will be out there.
So I was going to ask Dean, two of the things about 5G that I think are different from 4G is that 5G was developed with Internet of Things in mind. So historically, we had built our networks to deal with mobile phones, but now we've got phones and other sensors and computing devices. The other thing is that 5G is a technology that enterprises can use themselves. Tell us a little bit about that.
I disagree that. I think we've had machine-to-machine running on 2G and 3G and 4G, whether it's water meters or all sorts of other devices for a long time. For consumer IoT, perhaps not quite as much. The issue, and this also fits with the enterprise question, is how you deliver public services from a carrier on private property, like inside a building or inside a factory or on a farm or something like that. And that brings not just the physics into the equation, but also jurisdiction, ownership, liability, responsibility, and so on. And so, for example, if you have a factory with a robot, which has got an automated arm that could kill a worker, are you going to run that on the public network, even if it's sliced? And if so, is the public carrier going to take legal responsibility if it kills someone? Because if it isn't, what you'll find is the enterprise will think, well, I'm going to be the one in front of the judge if there's a problem. So I want to own the network myself, because then at least I can tell my investors and my compliance department that I've done this is all my documentation of how I've tried to guarantee the network. I've got redundant multiple small cells for every robot or something like that. And so I think that paradoxically you end up with, rather than one big network sliced for all these applications, you end up with lots of micro networks. And you're seeing this in a lot of countries. And everyone talks about how 5G is going to transform industries. What they haven't realized is that the first industry to be transformed is the telecoms industry. And that's what we're going to see first.
So Hiroyuki, one of the other technology changes that some people believe is important is this concept of open radio access networks, where a service provider could literally mix and match various components in the radio network. It's very controversial, and obviously you in Japan have a competitor that's touting this OpenRAN as a major strategic advantage. Obviously, I'm not thinking you think that it's such an advantage, but what are the pros and cons of this approach?
Okay. Actually, I'm not responsible for the radio access, but I would like to tell you about that. Actually, Docomo is founding member of the OpenRAN Alliance, and that founded in 2018, and it's actively promoting the alliance so far. The purpose of OpenRAN is to freely combine RAN equipment from multi-vendors. As with the core network, the virtualization is being considered in OpenRAN. And the VLAN with general purpose server is also in scope. OpenRAN compliant interface have already been commercially deployed in Docomo's 5G network. And we have realized an optimal architecture with a free mix of vendors. And also, we are building a testbed for VLAN and working with partners to verify it. This is my situation about OpenRAN.
So Dan, one of the claims that I've heard about OpenRAN is that it slices your radio capex as much as 40%. And of course, people disagree about whether it's 40% or 20%. How do you see that?
Yeah, we've heard that as well for years now, and I think that the devil's in the details when it comes to OpenRAN and the cost structure. Right? What we've heard is some aspirational numbers so far, and it's clear that the digital portions of hardware will potentially benefit from cost savings by moving towards more of a black box type of model where it's a compute asset, no different than what's happened in enterprise computing these days. However, I don't think that we've seen that full benefit yet, and more importantly, you have to take a step back and look at, okay, well now I'm shifting essentially from a bespoke hardware to a commodity hardware plus software model. I've got to now shift to software licensing and software maintenance structure, still TBD in terms of cost for most. And then I also have to now look at this and say, well, what percentage of my overall capex is this impacting? Because it's not impacting antennas, it's not impacting radios. There's only so far that it goes in terms of the overall capital spending for a telco. So most of the telcos that we've spoken with and worked with on this topic, I would say aren't betting that this is going to be as revolutionary as it's been made out to be in terms of overall capital spending. Last thing I would say on this is it is also difficult to do this unless you are at a generational inflection point. If you're not, for many carriers, these decisions on 5G architecture and 5G spending and 5G vendors were made 3, 4, 5 years ago. And so we should be thinking about OpenRAN and virtualization, except in some targeted instances, as probably a 6G type of architecture and not so much for 5G. The 5G boat has already sailed on that.
Speaking of boats sailing, and one of the things I have heard since 3G is the people making the argument or trying to make the argument that some generation of mobile technology is going to replace Wi-Fi or something of that sort. What do you think of that?
No. For the most part, no. There are specific instances where you could make that an argument. So if you are putting a network for automated vehicles in a warehouse with lots of metal shelves, then actually possibly the propagation is better for 5G. Same thing, you could argue that in the parking lot of a shopping mall, where you want to have digital signs and you have to cover a large area, that perhaps makes sense. It depends on the local rules on spectrum and what you've got in terms of the applications. So there are certain use cases where there is likely to be a shift, but equally you might find that in some cases it goes the other way. And then actually that Wi-Fi, if it becomes easier to federate with things like open roaming, that perhaps lends you in a particular direction in indoor situations. There's also variables around which generation of Wi-Fi you have. And ironically, at the moment, in a lot of places, 5G gives better download speeds, but often Wi-Fi gives you better upload. And it varies, depends on whether the fiber into the building. But actually also, paradoxically, although it's not reliable or guaranteed, Wi-Fi latency today is often much better than current versions of 5G. It's quite common to get probably 3 to 7 milliseconds ping times on Wi-Fi if they've been decently engineered. So I think it varies. And going back to what Daniel said, I agree. I think OpenRAN at the moment is in, let's call it extended beta. And I think 6G is the general release. But there's specific operators or situations where OpenRAN will make more sense. So greenfield operators, Rakuten, Dish, they differ in terms of whether it's public cloud or private cloud. Maybe for cost-effective coverage extension in rural areas, rip and replace of, particularly at the moment, there's certain vendors that are being replaced, and that's a good opportunity to test out new vendor combinations. Another question is whether just bringing new suppliers into the market acts as a pricing lever on the existing incumbents. And so it might not be that OpenRAN is directly reducing capex, but indirectly via the lever of pricing.
Dan, Mobile operators obviously are touting use cases for private 5G, no matter who's owning the network and who is supplying the network. But are there use cases, as Dean has been suggesting, where you really would want to look at 5G as a private network solution for good business reasons?
Yeah, so I think we are still also very, very much in the early days of private 5G, or as our friends from Japan have called it, local 5G. And I think that we're seeing a lot of interest in it. But right now, and I'll point back to sort of two issues. One is, as Dean said, painting a clear picture of where private 5G can truly have advantages over Wi-Fi. Right? In many instances, Wi-Fi is good enough, or quite frankly, in a lot of use environments where you may be able to get with a wired solution and don't even really need a truly mobile solution. What we are seeing with private 5G is a lot of interest in trials, a lot of interest in looking at applications of it, particularly where you have wider areas that need coverage, you need a campus, you need a town. Those are all great examples for private 5G. The challenge we're seeing right now, though, is not a technical challenge, albeit devices are still hard to come by, particularly for a lot of IoT devices. The challenge we see right now is who is going to play the role of integrator in bringing all the pieces together. This could be a telco, and some telcos are looking to go down that path. It could be a traditional SI. It could be the systems vendors themselves. I spoke with one of the largest equipment vendors just 3 days ago about this very topic. And I would say they have not yet decided the role that they want to play when it comes to private 5G deployments. And it could also be a managed service provider that chooses to play this role. All of these are possibilities when it comes to private 5G. But for most enterprises today, they don't know who to turn to. Where do you go to actually get private 5G solution, and who can bring all the pieces together, including spectrum, in places where you may have to have licenses to manage it. So that's what we see. It's more of a business model problem today than a technology problem.
Hiroyuki, what is Docomo's response to people who raise these sorts of questions?
Okay. Actually, basically, I agree with Dan's opinions. And private 5G is considered to be an effective solution for enterprise users because it can provide exclusive service in limited areas. For example, in factories and campuses. Mobile network operators such as Docomo will use their existing frequency band and install dedicated base station each private 5G area. But in Japan, as Dan said, local 5G service in which dedicated frequency band are allocated to new operator only is starting to emerge. And MNOs like us can't get this dedicated frequency, but we think we can support those local 5G operators by area planning and operation of their network and so on. This is my opinion.
Good. One thing that I'd say is NTT, fixed NTT, offers private networks, private cellular as a service globally with its own, as a systems integrator or as like a solution provider. So I think that one of the things we'll see is operators operating outside of their domestic footprint. So in the UK, the Port of Southampton has a private 5G network run by Verizon Business. Verizon doesn't have a cellular network in the UK, but it does private 5G for the port. And I think that there's three separate private network markets. There's and also, private cellular has been around for 20 years. So we've had private 2G, 3G, 4G. It's not new. Yeah, I saw my first private network small cell in 2001. So there's three markets. There's critical communications, which is things like utilities, rail, power infrastructure. Often it's not replacing Wi-Fi, it's replacing Tetra or P25 private radios. Then, and often for military use as well, you've got the indoor coverage with neutral host market, which is sort of private cellular as an alternative to DAS, distributed antenna systems. And then there's this sort of cloud IoT bit of private cellular. And there are three different markets that are, at the moment, fairly limited overlap. And I think that we focus on the cloud and IoT bit. It's where you've got all the systems integrators, you've got Amazon, you've got a number of the tower companies. So we had Digital Bridge earlier. They own a company in the UK called Freshwave that does a bunch of private cellular, and Cellnex as well. So I think that there's all sorts of interesting service providers, the tower cos, the cloud cos, the IT companies, the industrial systems providers like Siemens and Bosch and Honeywell. It's a really interesting mix of players here.
Dan, one of the questions that we hear a lot from service providers is, how am I going to make money from 5G? I've always found this a sort of interesting question. I think I know why they're asking it, but how do we make money from 5G? What are the pricing policies that you're seeing out there?
Yeah, I mean, and it's something that they've been asking, I'd say, for many years now. And I think if you ask a lot of operators, they would say, well, 4G actually wasn't a profitable investment for us in terms of return on investment. So how do we change this with 5G? With 5G, I think, again, as I said earlier, because we're still in the early days, we don't really have clarity on how 5G will be fully monetized. But we've got some early indicators. So right now, I would say for most networks around the world, 5G pricing is just like it was for 4G pricing, and maybe even hasn't gained a premium in most markets. We have seen operators work to move subscribers up the pricing ladder, if you will. So if they were on a limited plan, maybe now they're on an unlimited plan or something like that. Or if they were on a prepaid plan, maybe they're starting to shift to postpaid, which we're definitely seeing. We're starting to see some interesting experiments happen as well, but I'll say it's probably too early to judge, and most of them are very basic. So for example, one of the operators that we work with in Australia has established a pricing plan for gamers that offers reduced latency. And it's basically $10 Australian premium per month, a fixed price if you're going to do mobile gaming. Now, that's a very blunt instrument, and I would argue that that is only the first generation of pricing for latency that we'll see. What we haven't seen yet is that sort of in-game experience where you charge my teenagers, for an hour of being able to kill the other guy in the game faster, you charge them $1. And I know they would pay that gladly. We also, of course, haven't seen pricing for many of the advanced features that we were talking about that come with truly, standalone networks with network slicing, et cetera. How do I price for that quality of service? The thing that we see right now is most of the mobile network operators that we work with around the world honestly haven't got a plan in place yet for how to price for these capabilities, nor have they done the market testing to really understand what the market will bear for a lot of them. So we think this is a big opportunity, but for right now, it seems like the 5G premium is virtually non-existent.
Gentlemen, we've got about 15 seconds left, and I just wanted to thank you so much for joining us on the panel. I know it's challenging to be remote. I'd much rather have you here in the chairs with us, and next year we'll make sure that happens. Thank you so much. And thank you, Dean.
Thank you.